All right, so it occurred to me while I was preparing the lecture for normal probability distribution that we should probably do like a ChatGPT problem for a uniform probability distribution. And, we'll do that here. So can you please, and these chats will be available as a link, PDF document which you can download from our course resources in Canvas if you're taking this at the college. If you're watching this on YouTube, I'm sorry, you'll just need to come take the class at the college. Can you please give me a problem for me to work using the uniform probability distribution, work about the two uniform. We'll just see what it does with that. And we will wait. Here's a problem. Train travels between two cities and the travel time is uniformly distributed between 2 and 5 hours. Let the random variable x represent the travel time in hours. What is the probability density function for the travel time? So let's bring this over here and put it on the right. I'm pressing my window key and the arrow to kind of select something, move it to the left or right of the screen in Windows. So we have the probability density function here. And so what is the probability density function? We'll just like take all these here and we'll put them onto a notepad, boom. And this is an example of web stuff. And now I'm going to paste that there. The probability distribution function is going to be, we'll move this one over there too. It's going to be 1 over b minus a. So that's going to be equal to 1 over 5, what is it, 5 minus 2. Here we go, 1 over 5 minus 2, which is going to be 1 over 3. And that's for, let's see, it's between 5 and 2. So 2 is less than or equal to 5, to x is less than or equal to 5. And you make that equal sign. And I'll bring that closer like this. There we go. Just make it like that. That actually looks a little bit messy. We'll go like this. Calculate the probability that the train will take between 3 or 4 hours to complete the trip. So the probability that the train will take from 3 to 4 hours is going to be like this here. So we'll say 3 to 4 hours is going to be 4 minus 3. So it'll be 1 over 3. 1 over 3 times 4 minus 3, which is going to be 1 over 3, because that's 1/3 times 1. So we'll say it's going to take, and that's equal to 0.3333. So 33% probability, 33.33% probability that it'll take 3 to 4 hours. Calculate the expected value mean of the travel time. So the expected value mean is going to be a plus b divided by 2. And that's going to be 5 plus 2 is going to be 7 divided by 2 is going to be equal to 3.5. And calculate the variance and standard deviation for this travel time. And the variance is going to be 5 minus 2, which will be 3 squared, which will be 9 over 12. And that is equal to 3 over 4. And that is equal to 0.75. And so that's our variance. And then the square root of that, let's see if I can do that with a calculator. I'm going to bring up my calculator, and I'll do 0.75 and take the square root of that right there. And that's 0.8660 and 0.8660. And I'm just going to check square root. So I'm going to clear this. I'm going to do 4 and then do square root, and that's 2. So it gave me the right answer. So I'm going to put all that into ChatGPT and see what ChatGPT has to say about that. Here are my answers. Let's see if I got them right or if I have some room for learning, because I'm still learning statistics too. It's the second semester I've taught it. I did take it in grad school, but it's been a while. You correctly identified that the PDF which is the probability density function. That's kind of cool. It's 1/3 for 2, 2, 5. X is between 2 and 5. This is because the range of the uniform distribution is from 2 to 5 hours. So the length of the interval is 5 minus 2 is equal to 3. The height of the PDF is the reciprocal of the interval length, which is 1/3. Interesting. The length of the interval is 3, and the height is the reciprocal of the length, which is 1/3. That's interesting. Calculate the probability that the train will take between 3 and 4 hours to complete the trip. So here we have fx times b minus a, and where we have, the probability that x is between a and b. And so we have this b minus a. So fx is 1/3, and the interval from 3 to 4 hours is b minus a, so 4 minus 3 is equal to 1. So 1/3 times 1 is equal to 0.33, so that's correct. And calculate the expected value mean of the travel time. And so 3.5 hours, that's what we got. And calculate the variance, and it's 9/12, it's equal to 0.75. And the standard deviation square root is 0.866, so I got all those right. So that's an example of using uniform probability distribution and the density function in action.